All right, so what we're doing with integration with substitution is we need this for any time you have a question where you would have used the chain rule. So if we go backwards for a second and I said f of x was equal to 2x to the third plus 4 to the fifth power. To take the derivative of that, we needed to say that u was equal to 2x to the third plus 4, right? What's the derivative of du? That would be 6x what?
6x squared.
Mm-hmm. dx, right? Because that was all over the derivative for x.
Mm-hmm.
So then this would just equal what? 5 comes out front. This then becomes and stays the same. This is 2x to the third plus 4. I subtract 1, so that becomes 4, times the derivative of what was inside, which was 6x squared. Multiply those two together, and I get 30x squared times, it's not 5, times 2x to the third plus 4 to the fourth power, right? So integration is just what? Integration is the antiderivative, meaning going backwards. So in order to go through and take the integral of 30x squared times 2x to the third plus 4 to the fourth power dx, if I take the integral of that, what should I get? Absolutely should go ahead and go back to my original function. So anytime you're looking at something and it looks like you would have needed to use the chain rule, you have to use substitution. I'm going to be looking for and ask you to find du. And I'm going to ask you to write the integral in terms of u. So think of this as the different steps that you're going to have to go through and do. And then finally, integrate. For your final answer. So these are all your checkpoints that you're going to go through. First, you're going to go through and find out what u is. When you find du, you must put the differential in there, which is, in this case, we'll have a dx. If you don't put the dx in there, you will absolutely lose points. To find du would be our first step. So if I'm going to go through and find du, that is just going to equal negative times 5. So that's going to be negative 15x to the fourth dx. So I found du. You, again, must write this in terms of dx, and you're going to see why in a second. Now, I'm going to just make this a little bit smaller, stick that up here. So the next thing I told you we have to go through and do is write the integral in terms of u, right? Well, in order to write this integral in terms of u, I'm going to rewrite this. Now I'm going to write it with my inside piece first, that 3x to the 5th minus 1 to the 5. And I'm going to put the negative 15x to the 4th dx over here. So I have to replace things. So I've already said that all of this here is what? All of this inside here is u, right? Well, how do I replace this over here? Right now, this is all very nice. All of this represents what? Isn't all of that du? All right, so now I can go ahead and rewrite my integral. So now my integral is just u to the 5th du. And this is what I'm going to say. When I'm checking your tests, this is what I want. When I say I want to see the integral rewritten in terms of u, that's what I want to see. Now your final answer is the integration. My final answer is now I integrate this. I get u to the 6th. That's because it's 5 plus 1 all over 6 plus my constant. Now I go back, and what's my last step? My final answer should be in terms of x. So I plug x back in. So now I just write this as negative 3x to the 5th minus 1 to the 6th power all over 6 plus my constant.